Hello, Professor. Myself, Navin Chetri, with my teammate Sunimi Karki, with our offline activity 4. In our MQTT publisher.py, this Python script acts as an MQTT publisher, which simulates a temperature sensor and publishes both sensor data and student information via an MQTT broker using WebSockets. Basically, it connects to a public EMQX broker on port 8080 using WebSockets. And we have three topics for sensor slash temperature, and student 1 Navin Chetri slash 8002911 and student Karki slash 800286582, which randomly publishes temperature values between 50 and 100 to the topic sensor slash temperature, and our student name and student number respectively. Using random, it randomly selects one of the two students and publishes their name and student ID to either the topic Navin slash 800291016 or Tsunami 800286582. It repeats the process every 2 seconds, continuing the program until it is terminated without any keyword interrupt. And in our index.html, we subscribe to the same MQTT broker and listen for messages from the MQTT topics. It uses the MQTT.js library to connect to the broker and subscribe to the topics sensor slash temperature and our student topic, which are basically the topic student 1 and student 2. It displays the sensor temperature values in real time, updating the status to normal or alarm based on whether the temperature exceeds a predefined threshold of 75, and together displays the student name and ID. As you can see, it displays the student name and ID when a message is received in a tabular format. It updates the display values on the web page as we receive the MQTT messages from the MQTT publisher.py.
Now let's jump to the reflection questions. Question number 1. First off, what is MQTT? It's actually a communication protocol that's super lightweight and efficient, especially for IoT applications like ours.
Oh yeah, so in this project, MQTT allows real-time communication between the temperature sensor and our dashboard. The sensor acts as a publisher, sending temperature readings to a specific topic. Let's say sensor slash temperature in our case, and the dashboard is a subscriber, which listens for this update.
And what's really cool is that this communication does not require a constant connection, which is perfect for devices like ours that have limited bandwidth. It's really efficient for IoT, right, Nabil?
Exactly, Tsunami. MQTT is designed for constrained environments, making it ideal for IoT. Plus, it supports a different quality of service (QoS) levels, so we can ensure messages gets delivered reliably. This flexibility is a huge plus when with many devices.
And because it's lightweight, it also minimizes network traffic and reduces energy consumption, which is perfect for small, low-power devices like our temperature sensor.
And going to our question number 2, now let's talk about how the system triggers an alarm. This part is actually pretty straightforward. We set a temperature threshold, for example, 70 degrees Celsius in our case, and if the temperature goes above that, an alarm is triggered.
Yeah. So the temperature sensor constantly publishes its readings, and the dashboard checks if the value exceeds the threshold. If it does, it shows an alarm status with a red warning on the screen. If it's under the threshold, the status says normal with a green indicator.
Yeah, it's a simple threshold-based system. Very easy to implement, and it works well in situations where we need to know if the temperature goes beyond a certain point.
Exactly. But there are some limitations. Like if the temperature changes suddenly or fluctuates rapidly, we might get false alarms. And on the flip side, if the temperature increases slowly, we might not trigger the alarm early enough.
Yeah, that's really true. But in many real-world scenarios, this simplicity actually works out well. It's quick and efficient, which is exactly what we needed for most applications.
Now, moving on to question number 3. Let's move on to the real world applications. One that comes to mind is industrial monitoring, factories or production facilities where machinery can overheat.
Yes, definitely. Overheating machines are a huge problem, and if the temperature goes beyond a safe limit, it could lead to equipment failure. With this system, operators would get an instant alert, allowing them to take actions before things break down.
Exactly, Navin. And another great application would be in healthcare, right? For monitoring temperature-sensitive products like vaccines or certain medications.
That's a really big one. Hospitals need to keep those supplies at a specific temperature to ensure they remain effectively. Our system could alert them if the temperature goes out of range, helping them avoid any loss or wastage.
Right. So whether it's for industrial safety or healthcare, real-time temperature monitoring has huge potential in a variety of sectors.
Moving forward with question number 4, let's expand the system a little. While temperature is super important, we could add some other sensors to make the system even more comprehensive.
Totally. One sensor that works well is a humidity sensor. We know temperature and humidity often go hand in hand, especially in things like agriculture or food storage. If we are monitoring temperature in a greenhouse, for example, we would want to track both to ensure optimal conditions for plant growth.
Exactly, Tsunami. Humidity is just an important in environment like this. And then there's also the options of adding a gas sensor to it.
Yeah, a gas sensor could detect things like carbon monoxide or methane. This would be incredibly useful for safety in industrial or residential settings. A gas leak combined with a sudden temperature change could trigger an immediate alarm.
Definitely. Adding multiple types of sensors would give us a more holistic view of the environment, reducing the chances of false alarms and making the monitoring system more accurate.
And yes, it will open up new cases like air quality monitoring or even disaster prevention systems where multiple parameters need to be tracked in real time.
Okay, to wrap up the things, MQTT is an awesome choice for IoT system because it makes real-time communication super efficient and it's lightweight, which is ideal for devices like temperature sensors. Thank you.
Thank you.
With many devices.